Welcome to the Aldol condensation dehydration reaction at Nazareth College. This experiment is considered a green chemistry or sustainable chemistry experiment. The reason is it is completely solvent-free. It's also exciting because in this aldol condensation, we will be making a carbon-carbon bond. This reaction is a mixed aldol condensation because we will be starting with both 3,4-dimethoxybenzaldehyde and 1-indinone. Typically, mixed or crossed aldol reactions end up with a multitude of products depending on which alpha hydrogen is pulled off to form the enolate. However, in this reaction, only one of our reactants contains alpha hydrogens, therefore the reaction can produce good yield of a single product. This base catalyzed reaction is going to first form the enolate by pulling off the alpha hydrogen, and then that enolate will attack the electrophilic carbon of the other carbonyl compound in the reaction to form the beta hydroxyketone or aldehyde intermediate. Finally, dehydration will take place. We will form our alpha beta unsaturated aldehyde product. This is exciting. We are doing green chemistry and creating a new carbon-carbon bond at the same time. I have to be honest, this is a pretty neat reaction. Check it out. Our first reactant, 3,4-dimethoxybenzaldehyde, we will measure out about 1 gram. And our second starting material is 1-indinone, and we will measure out about 0.8 grams. Both of these solids will be transferred into a beaker for the reaction to take place. Once both solids are added to the beaker, we will stir the reaction for more than 5 minutes actually. It's sped up here so that you don't have to just sit and watch me. But I stirred for more than 5 minutes. What happens is both of these reactants, the 3,4-dimethoxybenzaldehyde and the 1-indinone, have very low melting points. So when they are mixed together, their melting points are lowered. Remember the melting point depression that happens when things are impure. And so once those melting points are both lowered, they actually both turn into liquids so that they can mix together nicely. If you're watching closely, you can see liquid is actually starting to form. It's actually pretty cool. Separately, measure out 0.24 grams of sodium hydroxide and using a mortar and pestle, crush the sodium hydroxide pellets into a nice fine powder. You have to be careful here as to not inhale any of the dust that forms from forming this powder, so the instructor should do this part. Once the oil has formed, add the sodium hydroxide to the mixture. Continue to mix and scrape until the mixture becomes a solid. Let the substance stand for 15 minutes once the solid is formed. I have sped the reaction up for you here as well. Just so you know, I stirred this portion for more than 3 minutes. Here's what it looks like after 15 minutes, and now we're going to add 10 milliliters of 10% hydrochloric acid solution. It is important when you're mixing to make sure all of the solid product comes in contact with the acid, so mix this thoroughly. For the record, I mixed this for about 1 minute. Using blue litmus paper, we want to verify that our reaction is in fact acidic. And it is. Now, using a Buchner funnel, we are going to collect our product by vacuum filtration. In order to get more of the solid, you can rinse your beaker with some more of that 10% hydrochloric acid. Now our product has impurities in it, so we are going to need to recrystallize with 9:1 ethanol water mixture. We're going to heat the ethanol water mixture and slowly add it to our product, continuing to heat both the product with the recrystallizing solvent and the solvent itself on a hot plate. Keep adding the recrystallizing solvent until most of the material is dissolved. I did end up adding a stir bar to the reaction to try to get the solid to dissolve as much as possible. Place a small amount of ethanol water in an Erlenmeyer flask and place it on a hot plate. Then we're going to filter the solution through fluted filter paper in a seamless funnel into that warm Erlenmeyer flask. This filtration using gravity does take some time as well, so be patient. Now I wanted to show you a little trick organic chemists use to get the stir bar out of a reaction. It's not called a thingamabobby, it's actually called a stir bar retriever. Once you've collected all the filtrate and cooled it to room temperature, crystals should start to form. In this case, however, I put the reaction on ice to speed up the crystallization process. I really think this is a fun part of the reaction to watch. It's neat how the crystals form right before your very eyes. Even on ice, this crystallization process took about 4 minutes. In real time, here is the ending of that process. Once all your crystals have formed, collect the product by vacuum filtration using a Buchner funnel. Leave it under vacuum for a few extra minutes to allow the product to dry, and then transfer your product onto a tared watch glass. Here's the mass of just the watch glass. Before you take the mass of your final product, set the watch glass with your product on it on top of the oven and allow it to drive a little bit more of the moisture off before you take your final weight. After about 10 minutes and once your watch glass has returned to room temperature, record your final mass. Now let's do the melting point. And the one analysis that we are going to do for this experiment is the melting point. And for the first time in this course, I have actually recorded the process of the melting point determination. The melting point apparatus right now reads a temperature of 171, And as the temperature increases, I will announce each time the temperature changes. Okay, good luck.
$172,
Determining the melting point range for your product is a tedious process. Not quite as bad as watching paint dry, but pretty darn close. So you have to really pay attention to any little tiny change.
$173,
For extra credit right now, email me and let me know what animal helped me determine this melting point.
174, $175, $176, $177, $178.
And now, safety with Jane. Subbing in for Jane is Dr. C. Make sure you wear goggles and gloves for this experiment and also work in the hood, as usual. Sodium hydroxide pellets are used in this experiment, and so we have to be careful. We are grinding the pellets into a powder, and so potentially some of it could become airborne as dust or mist, and this dust or mist could cause severe irritation of the nose or throat. As always, make sure we dispose of all waste in the hood, and at this point though, however, because the experiment is green, we do not have much waste at all. And that's actually going to be a post-lab question. And we'll look at the 12 principles of green chemistry again in this lab, and we will see which one or more than one of the principles of green chemistry apply to this reaction. Alrighty then, be safe and be green. There you have it, a green aldol condensation reaction. You have to admit, this one was pretty cool.